Top 10 Most Ingenious Construction High-Tech Inventions. Welcome to Tech Collective. Today we bring you the list of top 10 most ingenious construction high-tech inventions. It's been about 2.5 million years since the Stone Ages, when people occupied caves and depended on tools made of different stone forms. We have seen amazing achievements in the field of architectural engineering in the history of civilization, and we can say that the highlights of the architecture boom have arisen in the last 40 years. The most recent hardware component breakthroughs are exciting. Now, the market is driven by greater teamwork, research, and analytics software. Let's look at our amazing past of building technology by discussing the top 10 most innovative high-tech innovations in architecture. Don't forget to hit subscribe and click the bell to be notified of new content. 3D printed houses win our number 10 slot. 3D printed houses are a vision into the future. 3D house printing may entail the production of off-site pieces and the design of the structure on a separate occasion. It was invented by Corp and recently proven, based on San Francisco, that they can print 3D walls out of concrete in a very short time period. The printer, similar in design to a small-scale crane, sets concrete mixture blocks. 3D-built houses may be a perfect option for adapting efficiently to the housing needs of those impacted by extreme disasters such as tsunamis, hurricanes, and earthquakes, or those living in poverty. Number 9 goes to cloud and mobile technology. Over the past few years, we have noticed some important developments in technology. Online and mobile devices are two of those things. Widespread recognition of these two changes our lives, the way we do business, and much of our everyday tasks. Data from research and researchers demonstrate how widely these developments have reverberated in the business environment around the world. A proliferation in smartphones and portable devices also adds greatly to data traffic across the world IP. Because of its accelerated scalability, seamless network connectivity, on-demand self-service, and other technologies, cloud storage appears to be the best option to meet such data demand. We'll soon be exploring the concept of mobile cloud computing. We know that its computing speed, battery life, and storage hinder mobile devices. However, cloud computing offers an idea of unlimited power and computation. Mobile cloud computing is a modern technology that incorporates mobile devices with cloud storage to create a digital system by lifting computer-intensive activities heavily with storing vast volumes of data. Data collection and storage outside of handheld devices exists in this modern architecture. 8th position belongs to drones. Drone technology, also known as aerial unmanned vehicles, UAVs, is used in the construction industry for numerous purposes. The use of drones in building will bring multiple benefits as a platform that increases connectivity, protection, and marketing, collecting real-time photographs from the field. Building industry's sheer size and the projects being conducted on the African continent lend itself to the successful use of drones, that it can only add value if they are deployed safely and properly. Drones, like the transition of mobile phones to landlines, allows Africa to leapfrog old and obsolete technology and adopt the latest and successful technology to boost all industries, particularly in the construction industry, according to Mr. Adam Rossman of AMS in South Africa. Doing site inspections at a busy building site can also be risky and difficult. A drone's ability to conduct a visual assessment in high-risk areas will save time and reduce H&S dangers. Drone video can be captured from site cabin protection and then submitted easily and efficiently to project partners in HD. Place checks may be carried out more frequently to more effectively protect wider regions. Number 7 goes to Robotic Total Stations, RTS. A team using structural plans in a tape measure, spirit level, and theodolite, a precise tool for calculating angles, to locate access points for the likes of cable trays and pipework is the typical way to carry out construction facilities on a site. However, this approach does not fit well for more complex constructions. It is time-consuming and arduous and has a large margin for error, which can lead to significant effects, such as collisions with other construction facilities and unfitting prefabricated structures, resulting in lost time, resources, and materials. Enter Robotic Complete Stations, RTS, an electronic theodolite that can be remotely controlled from a distance, combined with an electronic distance meter. The project can be achieved by a single person using a tablet fitted with the necessary tools, with RTS ensuring better performance, enhanced precision, less errors, and less documentation, as well as decreased labor costs. Sixth place goes to advanced uses for GPS. GPS is used to identify where a job or service location is, and can then be used to arrange for the worker the most convenient path between locations, saving time, fuel, and eventually money. When personnel travel from site to site, supervisors can now trace the movements of staff and current positions using the GPS or GPS of the vehicle on a mobile computer, and building software apps such as a Communicata or Sage support operations. This gives you more control in your company when you are in a position to reach the worker closest to where you need them, thus greatly increasing productivity and the end result. This also enables you to ensure that all workers are where they should be throughout the day of work, and to see if they are on the most efficient route. If you don't actually use GPS in your building business, you're losing out on big benefits and time saves. Our number 5 is modular construction. Modular construction is a term used to describe the use of pre-engineered building units manufactured by a manufacturer that are shipped to the site and assembled as large volumetric parts or as substantive building elements. The modular units may shape whole spaces, room sections, or separate highly serviced units such as toilets or lifts. Collecting individual modular modules commonly forms a self-supporting structure in its own right, or may rely on a separate structural foundation for tall buildings. It is not just components like those mentioned above, but due to the growth of modular construction, entire buildings can now be made off-site too. Modules are constructed from the same materials and engineered to the same specifications as structures built on-site, but they cause much less damage to the environment. Components arrive on-site when and when needed. Today, when about 70% of construction is performed in the form of materials, it brings us into the world of just-in-time manufacture and distribution that slashes on-site delays and eliminates transport and waste. Number 4 is construction software and data ecosystem. Real-time shared computing is now used as an integral part of the overall development process. However, its impact on the sector is projected to grow considerably in the immediate future. It goes without saying that data has played an important part in the creation of this paradigm change. The creation of a technology community where all the industry's creative players come together to exchange data, expertise, to information about the project is closer than we would expect. And ensuring that this is the only path forward for the building is no exaggeration. The opportunity to merge the current processes and systems into a single, seamless, integrated application will improve the way people function within the industry. In the context of a building project, a plethora of technological applications for various functions and fields can now be integrated easily in one location. Using digital platforms enables the aggregation of these useful pieces of information and, by extension, reduces delays, rework times, and hiccups of content between site and office. Third place belongs to augmented reality. The AEC field, architecture, engineering, and construction, was out there longer than many other sectors on our planet. That is one of the reasons for slower adoption of emerging technology than in other domains. The McKinsey Global Institute Industry Digitization Index reinforced this fact, according to which the construction industry takes second to last position after evaluation based on over 20 metrics. The research and development (R&D) budgets are normally much lower in the construction industry than in other sectors. It barely crosses 1% in revenues. Second on the list is the growth of BIM. As building information modeling, BIM, is gaining traction in global construction, and as we are working further with BIM in the projects of our clients, we have witnessed and learned more about project problems that can be related to poor BIM processes. Typically, the BIM horror stories are embedded in the lack of technology acceptance and lack of attention to data processing and cooperation. First position goes to robotics. Robotic technology presents various benefits for the building field. The aim of automating processes and increasing efficiency is to use robotics to get work completed easier, cheaper, and with more accuracy. This article discusses some building fields that are influenced by robotic technologies, addressing its present effect on the market, as well as what you can hope to see in the future. One of the robotics applications is to enable greater automation of different processes. Automating these processes is becoming the aim in many areas of building, especially in the manufacture, packaging, and development. Hope you enjoyed the video. Which tech is the most advanced? Comment down below and let us know.